Hey, this is Mr. Preston. We're talking about special right triangles today. So you think you're special? Well, a couple of these triangles actually are. So if you're one of these triangles, maybe you're a little special. So what do we mean here? Well, 45, 45, 90 right triangles are called special right triangles because there's a certain relationship that exists when the angle measures of 45, 45, and 90. So let's take a look at what that is. So if I have a square, and I draw a diagonal through a square, I am bisecting these angles, right? So if this was 6, if my side length of the square is 6, I'm trying to find out what the diagonal is. Let's see here. This bisects the angle, so this becomes a, you guessed it, 45, 45, 90 right triangle. These side lengths are 6 and 6. And I can use the Pythagorean theorem to find this side length here, my hypotenuse. Okay, so I took a square, I drew a diagonal through it, and what I did is I bisected this angle. So now I have 45, 45, 90. So this is 45, this is 45, 45, 45, 90. What kind of a triangle does this form? Well, these are isosceles triangles. At least two angles are the same, at least two sides are the same. So if this is 6 and this is 6, I'm trying to figure out what this is. 6 squared plus 6 squared equals c squared. A squared plus b squared equals c squared. Why? Well, we have two side lengths here. 36 plus 36. Together, that gives me 72. 72 equals c squared. Can I pull a square root out of it? You betcha. So this is square root of 36 times the square root of 2. Square root of 36 is just 6. 6 square root 2. So this is 6 square root 2. Now what you'll notice is if we keep doing this, every time we do this, it's going to have the same result with the 45, 45, 90. If this was 8 and 8, this would be 8 square root 2. If this was 2 and 2, it would be 2 square root 2. Okay, so that's how we come up with this general diagram formulas and a set of formulas that we have up here. So x square root 2. So this is what you'll be seeing on the SAT. It'll give you this as a guide. So now let's solve some problems that involve this stuff. I'll leave this guy up here. So let's say you have 45, 45, 90. This is 10. This is, we're trying to figure out our hypotenuse. First thing you can do here is, these are my legs, leg, hypotenuse. Okay, so what you should be able to see here is my leg times the square root of 2 is my hypotenuse. Or my hypotenuse divided by square root of 2 is my leg. So I'm going to write that out. Hypotenuse equals leg times the square root of 2. So maybe from here you can just see that this is 10 and this is 10 square root of 2. If not, well, why is this 10? Because this is a, this angle corresponds to this side, this angle goes to this side. So this is, they're going to be congruent, that's 10. So let's use our, let me write this, I think, in better view here. So hypotenuse equals leg times the square root of 2. So hypotenuse equals leg, which is 10, square root of 2. And voila, there we have it. Leg times square root of 2. Let's look at a couple more examples. Let's say, instead of my leg being 10, my leg is going to be 7 square root 2. All this still applies. Okay, so once again here, I don't know what my hypotenuse is. My hypotenuse is unknown. I don't know it. So I'm going to find it out. So all I have to do here is plug into my formula. Well, what is it here? I have 7 square root 2. How do I get to this thing? I multiply it by another square root 2. This right here simply goes right there because it's a leg. So this is 7 square root 2 times square root 2. So 7 square root 4. And this reads as 7 times the square root of 4. The square root of 4 is 2. So this is 7 times 2. So this is just 14. So my hypotenuse is 14. 14 was my hypotenuse there. And my other leg was 7 square root 2. Okay, if that didn't make sense, I would suggest rewatching that or checking out the video on the multiplying radicals. But the multiplication there should have been pretty easy. I multiply what's under the square root. 7 square root 2 times square root 2 is 7 square root 4. Square root of 4 is 2. 7 times 2 is 14. What if we're given our hypotenuse? Let's say our hypotenuse, right, leg. Say my hypotenuse is 8 square root of 2. All I got to do is just stick with what I have. Hypotenuse equals leg times the square root of 2. Hypotenuse, I'm given that, 8 square root of 2 equals leg times the square root of 2. All right, so I'm trying to get leg by itself now. This is why this is so important right here. Because if we have this formula, all you have to do is plug in your numbers where appropriate, and you can find out any part of this that you want. We've already proven why this is x squared root 2. So here, 8 square root 2 equals leg times the square root of 2. So this is times. The opposite of times is divide, rather. I don't know, what is the opposite? So I'm dividing by square root of 2. What you'll notice here is these cancel. So my leg, the square root of 2's on both sides cancel. My leg is just nothing more than 8. A little weird looking 8 right there. So it's 8. So what did I do here? I had my hypotenuse. I plugged it in, 8 square root 2. And I was solving for my leg. Both sides had a square root of 2. I'm trying to get leg by itself, so I divide by the square root of 2. And I got my leg was equal to 8. All right, then let's take a look at one or two more. Let's say my hypotenuse is 10. Ooh. So once again, hypotenuse equals leg times the square root of 2. 10 is my hypotenuse equals leg times the square root of 2. I want to get this leg by itself, so I divide by the square root of 2. Okay, so this becomes 10 over square root of 2. This is when all of our skills on multiplying, dividing, all radical operations are just going to help us. So I cannot have a square root in the denominator, so I multiply the top and the bottom by the square root of 2. So this becomes 10 square root 2 over 2 times 2 is 4. The square root of 4 is 2. So 10 square root 2 divided by 2 is 5 square root of 2. Okay? 5 square root of 2. And that's special right triangles. Part 1, which was 45, 45, 90. Okay, so just remember hypotenuse is equal to your leg times the square root of 2. And I got that from my general formula, which you have here, or my general diagram, which you will be seeing on your SAT. Okay? Understanding special right triangles will help us in our later units as well, because we're going to be doing some stuff with trigonometry where we have to know our special rights.